On May 11, 2025, China successfully tested a new prototype of its Maglev magnetic levitation train, achieving an astounding speed of 620 miles per hour, 1,000 kilometers per hour. This remarkable milestone marks a significant leap in transportation technology as it surpasses the speeds of most commercial airplanes by 15%. The development not only showcases China's advancements in engineering but also positions the country at the forefront of next-generation transportation infrastructure. The technology behind Maglev. China's Maglev train operates using powerful magnets that lift the train above the tracks, effectively eliminating friction and allowing for unprecedented speed. The latest prototype utilizes a low-vacuum tube environment, significantly reducing air resistance. This innovative design is reminiscent of the Hyperloop concept proposed by Elon Musk, pushing the boundaries of what is possible in rail travel. The implications of this technology are profound. For instance, a journey from Beijing to Shanghai, which currently takes approximately 5 hours using conventional high-speed rail, could potentially be shortened to less than 1 hour with the new Maglev system. This leap in travel efficiency promises to reshape how people and goods move across vast distances. Environmental and economic benefits. The Maglev train prototype was developed by North University of China as part of a broader strategy to enhance connectivity within megaregions while promoting sustainable travel options. Its operation is entirely electric, offering a cleaner alternative to air travel and traditional rail systems that often rely on fossil fuels. The eco-friendly design minimizes energy waste and noise pollution, making it a more sustainable mode of transport. The economic implications of such a transportation revolution are significant. Faster travel times could stimulate trade and tourism, fostering economic growth in regions connected by the Maglev system. Cities could be transformed into interconnected hubs, allowing for greater mobility and accessibility. Contrasting development with the United States. Various sources have highlighted the stark contrast between China's rapid advancements in high-speed rail technology and the sluggish pace of similar developments in the United States. Critics argue that while China is setting new standards in transportation, the U.S. remains bogged down by bureaucratic delays and outdated infrastructure projects. The ongoing challenges faced by America's high-speed rail initiatives, such as the California High-Speed Rail Project, underscore the difficulties in implementing such systems in a country where political will and public consensus are often hard to achieve. The timeline of development. The Maglev train prototype was first unveiled in January 2021 at a test track in Chengdu, Sichuan. Since then, tests have confirmed its capabilities, making it a significant symbol of China's commitment to innovation in transportation. The prototype's successful testing on May 11, 2025 represents a culmination of years of research and development, positioning China as a leader in the global transportation landscape. A geopolitical statement. Beyond its technological achievements, China's Maglev train represents a geopolitical statement. The ability to develop and deploy such advanced infrastructure not only demonstrates China's engineering prowess but also signifies its intention to lead globally in sustainable and efficient transportation solutions. As the world watches, the Maglev train serves as a reminder of the potential for innovation when there is a coordinated vision and the political will to see it through. Conclusion. In summary, China's Maglev train hitting a record speed of 620 miles per hour is not merely an engineering marvel, it is a bold statement of the country's vision for the future of travel. As it stands, the U.S. faces questions about its competitiveness in the global transportation arena. The implications of this new technology extend beyond speed. They encompass environmental sustainability, economic development, and geopolitical strategy. With the successful testing of this Maglev prototype, China is not just advancing transportation technology, it is redefining the future of travel itself. China's recent testing of a Maglev train prototype that reached a staggering speed of 620 miles per hour, 1,000 kilometers per hour, has raised eyebrows worldwide, particularly in the realm of transportation technology. This remarkable speed not only surpasses that of most commercial aircraft by 15%, but it also represents a significant leap in engineering capabilities. The train utilizes magnetic levitation, allowing it to float above the tracks and eliminate friction, and operates within a low vacuum tube that reduces air resistance, echoing aspects of Elon Musk's Hyperloop concept. One of the most counterintuitive points here is not just the speed at which the train operates, but the potential implications for travel time between major cities. For instance, the journey from Beijing to Shanghai, which currently takes around 5 hours by conventional high-speed rail, could be reduced to under 1 hour with this new Maglev system. Such a drastic reduction in travel time challenges the traditional reliance on air travel for long-distance journeys and raises questions about the future viability of aviation for domestic travel in regions with high-speed rail options. Moreover, the environmental implications of this Maglev train are noteworthy. The system is entirely powered by electricity and claims to offer a cleaner alternative to air travel and traditional fossil fuel-dependent rail systems. This shifts the narrative around high-speed rail, typically seen as a less efficient means of travel compared to air transport, to one that emphasizes sustainability and energy efficiency. The design minimizes energy waste and noise pollution, which positions it as a more environmentally friendly option. In addition to technical advancements, the geopolitical implications of this project cannot be overlooked. The rapid progress of China's Maglev technology starkly contrasts with the United States' sluggish pace in developing high-speed rail infrastructure. Critics in various media sources have pointed to the bureaucratic challenges and infrastructure delays in the U.S. as a stark comparison to China's streamlined and ambitious transportation goals. This situation underscores a broader narrative about national competitiveness and innovation in the global arena. While Japan and Germany also have their own Maglev systems, China's achievement is often framed as a demonstration of their ability to scale these technologies more effectively and publicly. The implication here is that not only is China advancing in speed and technology, but it is also setting the standard for the future of transportation, leaving other nations to play catch-up. The article also touches on the commercial potential of this technology, suggesting it could reshape long-distance travel dramatically. With the ability to connect sprawling megaregions quickly, the Maglev system could redefine urban connectivity and create new economic hubs, fundamentally changing how people think about distance and travel. In summary, the counterintuitive aspects of this development lie in the combination of unprecedented speed, environmental benefits, and the geopolitical implications of China's advancements in transportation technology, particularly in stark contrast to the United States' current trajectory in infrastructure development. China's recent achievement of a Maglev train prototype reaching 620 miles per hour is significant not only for its revolutionary technological implications but also for its broader socio-economic and geopolitical context. While many reports will highlight the incredible speed and technological advancements, several critical aspects may be overlooked that warrant deeper discussion. 1. Environmental impact and sustainability. The Maglev train operates on electricity and is designed to be more energy efficient than traditional transport systems. This focus on sustainability is crucial as global transportation contributes significantly to carbon emissions. The Maglev system reduces friction, which in turn lowers energy consumption and noise pollution. As climate change becomes an increasingly urgent issue, advancements like these could be pivotal in shifting global transportation towards greener alternatives. This aspect, often overshadowed by the excitement of speed, underscores a strategic alignment with global sustainability goals, suggesting that rapid transit can coexist with environmental responsibility. 2. Technological leadership and innovation race. China's rapid development of high-speed Maglev technology reflects its ambitions to lead in the global technology landscape. This achievement positions China not merely as a participant but as a front-runner in the transportation sector, potentially redefining global standards. The implications extend beyond transportation. They signal a shift in technological hegemony, with China demonstrating its capability to innovate at a scale and speed that challenges established players, particularly the United States. The geopolitical ramifications of this technological leadership could reshape international relations, trade, and economic dominance in the coming decades. 3. Infrastructure development and economic connectivity. The Maglev train is part of a larger infrastructure strategy aimed at enhancing connectivity within China's sprawling megaregions. By linking cities like Beijing and Shanghai in under an hour, the Maglev system could transform regional economies, allowing for more fluid movement of people and goods. This has implications for urban planning, economic development, and even population distribution. The potential for economic hubs to emerge outside major metropolitan areas could alleviate congestion and promote balanced regional development, a consideration that is often lost in discussions focused solely on speed. 4. Contrast with U.S. infrastructure challenges. A significant narrative that may be overshadowed is the comparative analysis with the United States' struggles in developing high-speed rail infrastructure. The U.S. has faced numerous challenges, including bureaucratic inefficiencies, funding issues, and public resistance to large infrastructure projects. This disparity raises questions about national priorities and the ability to adapt to changing transportation needs. While the U.S. grapples with aging infrastructure and a slow pace of innovation, China's advancements serve as a stark reminder of what can be accomplished with political will and strategic investment. It prompts a national dialogue on infrastructure priorities and future readiness. 5. Public perception and adoption. The potential public reaction to such advancements both in China and abroad is an important aspect that may be overlooked. In China, the government's role in promoting and funding these projects could lead to broad public acceptance fueled by national pride and technological achievements. Conversely, in the U.S. and other regions, public skepticism around high-speed rail has often stemmed from concerns about costs, environmental impacts, and practicality. Understanding these public perceptions is crucial for any future initiatives aimed at adopting similar technologies elsewhere. 6. Long-term economic implications. The economic implications of transitioning to maglev transportation are profound. Faster travel times can lead to increased productivity as business trips become more efficient. And tourism could see a significant uptick as travel becomes more accessible. This shift could redefine not only how individuals perceive travel but also how businesses operate across regions. The transformation of economic landscapes through enhanced transportation networks is a critical point that deserves emphasis, as it can lead to significant shifts in labor markets and economic opportunities. 7. Potential for global influence and export of technology. China's advancements in maglev technology could position it as a global exporter of high-speed rail systems. As countries around the world seek to modernize their transportation infrastructures, China could leverage this opportunity to expand its influence through technology exports. This aspect ties into the Belt and Road Initiative, where infrastructure projects are central to fostering international relationships. The ability to export this technology could enhance China's soft power and create economic dependencies on Chinese technology, altering geopolitical dynamics. Conclusion. While the speed of China's maglev train is undoubtedly impressive, the broader implications of this achievement are equally significant. The environmental benefits, the potential for economic transformation, the geopolitical implications of technological leadership, and the contrasts with U.S. infrastructure challenges all paint a complex picture of what this advancement means for the future of transportation and global dynamics. Recognizing these facets transcends the immediate excitement of technological progress and invites a deeper conversation about the future of travel, urban development, and international relations. 1. Technological innovation and speed. China's maglev train prototype, which recently achieved a speed of 620 miles per hour, 1,000 kilometers per hour, represents a significant leap in transportation technology, surpassing the speeds of most commercial aircraft.
The train utilizes magnetic levitation to eliminate friction and operates within a low vacuum tube to reduce air resistance.
This innovation not only enhances speed but also showcases China's commitment to advancing transport infrastructure. 2. Environmental sustainability. The Maglev train operates entirely on electricity, presenting a cleaner alternative to traditional forms of transportation that rely on fossil fuels. The design minimizes energy waste and noise pollution, making it a more sustainable option for long-distance travel. This aligns with global efforts to reduce carbon footprints and promote eco-friendly transportation solutions. 3. Economic and urban transformation. The potential of the Maglev train to drastically reduce travel times has far-reaching implications for economic development and urban planning. For instance, a journey from Beijing to Shanghai could be cut down to under 1 hour, facilitating greater connectivity between megaregions. This could lead to new economic hubs, changes in commuting patterns, and a redefinition of urban landscapes, promoting tourism and decentralizing overcrowded metropolitan areas. 4. Geopolitical implications and global competitiveness. The advancement of China's Maglev technology raises questions about the United States' position in the global transportation sector. While China rapidly innovates and rolls out new technologies, the U.S. struggles with bureaucratic delays and outdated infrastructure. This disparity not only highlights the need for the U.S. to invest in high-speed rail but also signals a broader geopolitical narrative where infrastructure development becomes a tool for national prestige and competitiveness on the world stage. Here are 3 famous historical cases that are similar to the advancements and achievements represented by China's Maglev train hitting record speeds. 1. The launch of the Concorde 1969. The Concorde, a turbojet-powered supersonic passenger airliner, was developed jointly by British and French engineers and first flew in 1969. It was capable of cruising at speeds over twice the speed of sound, Mach 2, significantly reducing flight times across the Atlantic. The Concorde represented a major technological leap in aviation akin to what China's Maglev train signifies for ground transport. Just as the Maglev train operates in a low vacuum tube to reduce air resistance, the Concorde's design utilized advanced aerodynamics to minimize drag at supersonic speeds. The Concorde became a symbol of luxury and innovation in air travel, establishing a new benchmark for speed and efficiency in commercial aviation. 2. The completion of the Transcontinental Railroad 1869. The completion of the first transcontinental railroad in the United States marked a significant milestone in transportation history. Finished in 1869, it connected the eastern U.S. rail network with the Pacific coast, drastically reducing travel time across the country. The railroad facilitated the movement of goods and people, transforming the American economy and society. Similarly, China's Maglev train aims to enhance connectivity between major cities, promising to reduce travel times and promote economic growth in sprawling megaregions. Both represent ambitions to revolutionize transportation, with the Transcontinental Railroad setting the stage for modern rail travel. 3. The introduction of the high-speed Shinkansen in Japan 1964. The Shinkansen, or bullet train, was introduced in Japan in 1964, just in time for the Tokyo Olympics. The original line connected Tokyo and Osaka, allowing trains to operate at speeds up to 210 km per hour, 130 miles per hour, which was revolutionary at the time. The Shinkansen set the standard for high-speed rail travel worldwide, emphasizing safety, punctuality, and efficiency. China's Maglev train, with its remarkable speed of 620 miles per hour, extends this legacy into a new era of rail travel. Both the Shinkansen and the Maglev train showcase the potential of rail technology to transform travel, facilitate economic growth, and serve as symbols of national pride and technological prowess. These historical cases reflect the continual evolution of transportation technology, each representing a leap forward in speed and efficiency, much like China's recent advancements with its Maglev train. Future outlook: China's Maglev train and the future of transportation. As China's Maglev train reaches a record speed of 620 miles per hour, 1,000 kilometers per hour,
The implications for the future of transportation are profound and multifaceted. This technological advancement not only showcases China's leadership in transportation innovation but also sets a new benchmark for global travel.
Here are several key predictions and potential developments stemming from this remarkable achievement.
1. Redefining travel times and urban connectivity. With the capability to travel from Beijing to Shanghai in under an hour, the Maglev train will drastically reduce travel times, fostering stronger economic and social ties between major cities. This could lead to the emergence of megaregions where people can live farther from their workplaces, promoting a shift in urban planning and development. Cities may evolve into interconnected hubs rather than isolated metropolitan areas, reshaping the landscape of regional economies. 2. Environmental sustainability and energy efficiency. The Maglev train operates on electricity and generates minimal noise pollution, making it a more environmentally friendly alternative to both air travel and traditional rail systems. As countries worldwide grapple with climate change, China's Maglev technology could inspire similar initiatives, prompting a global shift toward electric and sustainable transportation systems. This could lead to increased investments in clean technologies aligning with international climate goals. 3. Global competition in transportation technology. China's advancements in Maglev technology could intensify competition in the global transportation sector. Countries like Japan and Germany, which have their own Maglev systems, may feel pressured to innovate further or expedite their own projects to remain competitive. The United States, which has lagged in high-speed rail development, may face calls for renewed investment in infrastructure reform to catch up with China's rapid advancements. 4. Economic opportunities and job creation. The commercialization of Maglev technology could spur significant economic growth. The construction and maintenance of Maglev systems will create jobs from engineering to manufacturing and operations. Additionally, improved transportation could boost tourism and local businesses, leading to broader economic benefits in regions served by these high-speed trains. 5. Technological advancements and innovations. The success of the Maglev train could catalyze further innovations in related technologies such as high-temperature superconductors and vacuum tube systems. As research and development in these areas progress, we might see additional applications beyond transportation, including advancements in energy storage and magnetic technology. This could position China as a leader in various tech sectors, influencing global markets and technological standards. 6. Impact on air travel and aviation industry. As Maglev trains provide an efficient alternative for medium-distance travel, the aviation industry may need to adapt. Airlines could see reduced domestic travel demand, particularly for routes that align with Maglev train paths. This could lead to potential restructuring within the airline industry, with airlines focusing on long-haul international flights rather than short domestic routes, prompting a re-evaluation of air travel economics. 7. Challenges and regulatory considerations. Despite its potential, the deployment of Maglev technology will not be without challenges. Regulatory hurdles, safety standards, and public acceptance will play critical roles in the widespread adoption of this technology. Governments around the world will need to address these challenges, possibly leading to new regulations and standards for high-speed rail systems. 8. Shift in public perception and travel trends. The introduction of high-speed Maglev trains could alter public perception of long-distance travel, shifting preferences toward trains over planes. As travelers seek faster, quieter, and more environmentally friendly transportation options, we may see a cultural shift in how people perceive and utilize travel infrastructure. The convenience and efficiency of Maglev systems could lead to a resurgence in train travel as a preferred mode of transportation. 9. Potential for global collaboration. As nations observe the success of China's Maglev technology, there may be opportunities for international collaboration on infrastructure projects. Countries could partner to develop high-speed rail systems that connect regions across borders, fostering economic cooperation and enhancing global trade. This could lead to a new era of collaborative infrastructure development, with shared technological advancements benefiting multiple nations. Conclusion: China's achievement in developing a 620 miles per hour maglev train is not just a milestone in transportation technology, it represents a paradigm shift in how we envision the future of travel. As the world watches China set new standards, the ripple effects of this innovation will likely transform urban connectivity, economic landscapes, and environmental strategies. The next decade will be critical in determining how countries respond to this challenge and opportunity, shaping the future of transportation for generations to come.